Hey guys, this is Aaron. So we started into this thing with Solid Tools, and I started to put together some workflows for Solid Tools and some tips and tricks, that kind of thing. But I figured before anything else, you should probably touch on the pieces of Solid Tools. What are the 6 tools that are part of Solid Tools, and how and when do you use them? So I kind of tried to come up with some examples of how each of the Solid Tools would be used. So with that, we'll go ahead and hop right in. Okay, so here I have the Solid toolbar turned on. So there's only 6 buttons. It's a pretty simple toolbar. On here we have each of the pieces: outer shell, intersect, union, subtract, trim, and split. So I want to just run through how each of the 6 of these work and where you might actually use them. So I figured a couple cases for each one with just 2 groups. So I can click on either one of these. If I turn empty info, I can see these are both solid groups. So as this is the image for the shortcut key, let's see how it actually works. So if I select one of these, click on the first one, we're looking at union first. I'm going to click on union, click the other. What happens? They become one piece. That's how union works. So when would you want to use this? Well, I got an example right here. So I have this little super basic, super simple mallet thing. Right now it's 2 separate pieces. So I have a solid here, and they just kind of run through each other. Obviously, if I try to move one of these, it's not going to move the other. So I could go grab these 2 and group them, but they'd be 2 separate pieces. If I want to make them one piece, I could select one, I could click union, and I could click the second. And now I have one brand new solid that has been unioned. Can you use union like a past tense verb? Anyhow, that is an option. Okay, so how is that different from outer shell? So what outer shell is going to do, the results actually in the simple example will be very similar. Because if I select one, I hit outer shell and select the other, it's going to create pretty much the same thing. A neat thing about outer shell too is, if I go ahead, undo that, is outer shell will let you grab a bunch of pieces at once and click outer shell. So if I look at this right here, this is a good example of what outer shell does. So if right here I have a little house, so I'll let me take these pieces and just move them vertically so you can actually kind of see what's inside here. So here I have a roof, I have these walls are a group, and then here I have a floor that has a table built into it because training example, that's why. So if I was to just take this as it is, I could one at a time make these pieces go together using something like union, and I'd have a solid at the end. That would be not a problem, that would be easy. The difference with outer shell is when it joins this geometry together, it's only going to be concerned with what's on the outside. So things like the insides of these walls or the doors or the geometry of the table are going to all disappear when I select it all and click on outer shell. See that? So that is the big difference between union and outer shell. Union will combine geometry together, but if there's voids or geometry on the inside, as long as they're all touching and it makes a solid, it's going to honor it. Outer shell wipes it all out and only keeps the exterior faces. So that's the big difference between those two. All right, now we have subtract. So let's see how that works. So subtract is going to take away from one geometry's mass from another. So there we go. So something that's very important with subtract is the selection order. You want to select the cutter first and then what is to be cut. So here, if I have this plate right here and I want to put screw holes into it. So what I have is a bunch of basically dowels at the corners. So what I would do is I would select one of these, I would say subtract, and then pick the main plate. And that will put a hole through there. So it's real important, select what you want to subtract first, then choose subtract and select what is going to be subtracted from. So you can see that's time consuming. My desire would be, of course, to select multiple, hit subtract, and notice that doesn't work. Because what it just did is it subtracted one geometry from another. So what happens if I do this, select 3 and hit subtract? Well, it tells me it requires exactly 2 solids. So with subtract, your only real option is one at a time to come through here and subtract these out. That's your only option right now. In later videos, we'll get into how to actually make that happen a little bit quicker and easier, but that's the basics of how subtract works, which is similar but not the same function as trim. So the way trim works, it's also going to take geometry away from another geometry. So I'm going to select, the rule still applies. What do I want to cut first? What's my trimming piece? What's my subtracting piece? My trimming piece I'm going to select first. Then I can click on trim and then select the other piece. The way this differs from subtract is, you can see that, look at that, it keeps my original geometry, my cutter, intact. So if I wanted to take this piece right here, which is just a push-pulled hexagon, and I want to actually bore out the threads for this bolt to go through, so I'm going to create a nut, what I could do is select, first, like I said, the cutting geometry, choose trim, and then pick on the piece that I want to have that cut out of. With that, there we go, it cut those threads out of the solid shape. So this is really nice. When over here I had throwaway cutters, I just had extruded circles that were just going to get thrown away, no big deal. Here, if I had used subtract, I would have got this nut, would have been great, but my bolt would have been discarded because it would just use it as a cutter and then throws it away. So that's the big difference there between subtract and trim. Similarly, we have down here intersect and split. So the way intersect works is I'm going to select one geometry, then choose intersect and choose another, or select 2 geometries. Either way works. But when I hit intersect, I get just the leftover geometry, just where they crossed. So anything that falls outside of the overlapping geometry is discarded. So say I want to do something like this. I have this little dome shape, and right here I have this crinkly outline. So let's say I want to use these 2 geometries and I want to make like a peanut butter cup or something like that. Well, not something like that. That's exactly the geometry I want to create. So you can see here I have my dome piece is one set of geometry, and then down here my, I don't know, crinkling, undulating outline, whatever you want to say, back and forth all the way around is a separate geometry. So if I select both of these and then I click on intersect, that's what I end up with. You can see it kept that dome geometry and it got the outside there. Only the pieces that overlapped were kept. Everything else was discarded. So how is that different from split? Okay, so I know I cheated here. I had the same example twice, but for the life of me, I could not figure out another example for split. So let's see what happens. So I'm going to select both these 2 pieces. I'm going to choose, rather than choose intersect, I'm going to choose split. And it looks like nothing happened, but what happened was this piece got cut and this piece got cut. So split acts very, very similar to the way that intersect does, but it leaves all the pieces behind. So this is now a single piece. It's not the 2 pieces that intersected. It's just a single piece and these 2. So if I take that same peanut butter cup example, peanut butter cup, and I say select both of them and then click on split, what I end up with is something like this. There's the piece that got cut off the top. Here's the piece that got cut off the bottom. So I end up with all 3 pieces sticking around. So there may be situations where you're creating an assembly or something like that where geometry is going to overlap and you want to break it. And split's great for that because it will actually maintain all that geometry. So there you go. That is Solid Tools in a nutshell. Hopefully those different examples help you remember which is which. I still sometimes have to, in my head, run through, wait, what does this do again? And you guys probably saw me, I kind of had to hover a couple times there. I don't always remember exactly which icon is which. But those are some, I think, pretty solid examples of how the tools work, and hopefully that helps clear up any confusion you have, or maybe this is the first time you've seen anything on solid tools, and hopefully that's a good way to cement them in your brain as to how they work. Hopefully you did like that too. If you did like, go ahead and click like down below. And if you haven't already, click on the subscribe button. We create several videos a week and you'll be notified when each of them come out if you're subscribed. Most importantly though, please leave us a comment. The idea to cover the solid tools was actually submitted in a comment on a YouTube video, a couple comments, so that's why we're doing it. We like making these videos a lot, but we like them even more when they're showing something that you want to see. Thank you.